In the fall of 2012, the math department began to discuss what could be done to improve the outcomes of students in our developmental math courses. For far too many students, failure in developmental math blocks academic opportunities and plans. This is particularly true for students pursuing careers in non-STEM majors. This is not only a concern on our campus, but nationwide, and schools across the country are embarking on developmental redesign projects designed to improve the success rates of students in developmental math. We surveyed what other schools were doing and devised a plan that we'd like to share with you in this video. We hope that this video addresses some of the questions and concerns that you might have about this redesign, again with a special focus on non-STEM students. We've all heard of this idea of quantitative reasoning, and we know we want our students to have quantitative reasoning skills. Here's one definition. A person who's competent in quantitative reasoning possesses the skills and knowledge necessary to apply the use of logic, numbers, and mathematics to deal effectively with common problems and issues. So whether it involves reading a table and interpreting data, working with a formula such as this formula for compound interest, modeling the half-life of a sleeping pill in a patient's system, or modeling the population density of a certain population of bacteria, or calculating the break-even point of a new invention or a new innovation, we all agree that quantitative reasoning skills are very important. We want our graduates to be able to interpret and use mathematical formulas to represent mathematical information, including data, numerically, symbolically, and visually, using graphs, charts, and equations. And we want them to be confident problem solvers. We weren't sure that our current algebra sequence was really doing that, and again, this is a national conversation. Our current algebra sequence takes people from pre-algebra to elementary algebra to intermediate algebra. And these courses are very heavy on the symbolic manipulation, especially MAT-040, our intermediate algebra course. And again, we weren't really sure that it was preparing the students in the best possible way to take college-level non-STEM courses. After reviewing the literature, we found that there were two characteristics of successful redesigns: elimination of exit points and increased time on task. So the first thing we decided to do was to combine MAT 030 and 040 together to create MAT 035, Algebra for Non-STEM. This course will be based on real-world problem solving with a special focus on data, graphs, and mathematical modeling. It's going to emphasize collaboration and communication, and it will incorporate technology to enhance conceptual understanding, visualization, and inquiry. This course will allow students to piece together their existing mathematics knowledge, which is often fragmented, into a unified, cohesive whole. We're also going to introduce MAT 025, pre-algebra. This course will be 5 contact hours. It will also pull in a little bit of algebra from MAT 030. Many students who struggle with algebra are weak in basic arithmetic. It's hard to master algebra if you can't add, subtract, multiply, or divide without a calculator. For our student population, we've decided to increase the number of hours from 3 to 5 to give them a solid foundation in arithmetic. The bottom line is that with this redesign, students who need to build a basic foundation of algebraic skills, which is the majority of our students, will be able to complete their math requirement in 1 year. A student who needs to brush up on his or her arithmetic will need to take an additional semester, but the investment of time up front, review of order of operations, fractions, percentages, proportions, and other arithmetic skills will clearly benefit them as they continue their college careers. Note that the non-STEM college-level mathematics courses will have an extra credit hour added as of the fall of 2014 to ensure that there is time for technology and projects. The textbook that we've chosen for this redesign is Mathematics in Action. We like this textbook because it includes real-life examples and data. Every topic is introduced with a real-life example to give topics context. We also like the idea of mathematical modeling, taking data and trying to fit mathematical equations and graphs to that data. It's an activity-centered approach. It stresses collaboration. And finally, technology is embedded throughout the book, and it's used to enhance conceptual understanding, visualize concepts, and reinforce skills. We hope that you'll take some time to look through the book just to see how it's organized and see how radically different it is from the traditional algebra textbook. In terms of implementation, this spring we'll be offering the new courses MAT 025 and MAT 035. We'll still offer MAT 030 and MAT 040, but only to students who have successfully completed the prerequisites for those classes, or who need to retake MAT 030 or MAT 040. We will not be offering MAT 020 anymore. In the fall, most developmental students will be placed into MAT 025 and MAT 035. MAT 040 will be offered, but only to students who have successfully completed MAT 030 or need to retake MAT 040. MAT 030 will be retired. And then in the spring of 2015, MAT 040 will be retired. I'd like to talk briefly about other approaches that we found. The first is a modular computer-based approach using a tool such as MyMathLab. We believe that while computer programs such as MyMathLab are wonderful tools for practicing basic skills, the big ideas are best taught in a setting that emphasizes collaboration and hands-on activities. We also looked at alternative pathways such as Statway and mathematical literacy for college students. We were very concerned about the rigor of some of these programs, as they included just the algebra that they'd need to pass college-level statistics, for example. We're concerned that by watering down the curriculum, students will not possess the mathematical maturity to succeed in real college-level courses. Clearly, students need quantitative literacy skills to be successful in an increasingly technological and complex world. Another approach that we saw is to waive the developmental math requirement for most students. Most recently, this recommendation came from the Board of Higher Education's Developmental Math Task Force. Recent high school graduates and those whose high school GPA is 2.7 or higher are exempt from the initial placement exam and should be placed directly into the lowest college-level math course appropriate for their chosen pathway of study. We believe that just because someone is a recent graduate, it doesn't mean that he or she has a solid foundation. We have to face the reality that there are a large number of underprepared students who are not adequately prepared for college-level work in courses that require quantitative skills. When large numbers of these mainstream students fail to catch up academically, they'll be pressured to reduce standards in order to get them through. Now, parents, students, and employers already question the value received in return for a college education, and as standards are lowered further, the scrutiny will be even more intense. We really believe that strong quantitative skills open doors. Many of the decent, well-paying jobs of the future will require significant quantitative skills. We have to communicate to students that, although time and effort will be required, 4Cs has the resources to help, and students can do it. We want our graduates to have the best possible start, to leave here well prepared for additional education or the world beyond. If our students can take from our algebra sequence a comfort with variables and formulas, an ability to interpret graphs and to think logically, and a willingness to use abstraction when they try to solve problems, then they will have gained some incredibly useful quantitative skills. We can work together to help students be successful. We really need your help. Many of our students feel that their teachers have given up on them, and many of them have given up on themselves. We want them to become confident problem solvers, and we believe that our redesign effort is a step in the right direction. Please feel free to contact us with your questions and concerns, and thank you for watching.